10.3 Areas of Regular Polygons. As the name suggests, our objective in this lesson is to find the area of a regular polygon. And you remember that regular means equilateral and equiangular, so our angles are congruent and all of our sides are congruent. So we're going to start with some vocabulary here. If you circumscribe a circle about any polygon, and you remember circumscribe means to draw a circle around the outside of our polygon, intersecting all of the vertices, the center of a polygon, of our regular polygon, is the center of the circumscribed circle. So here is our center. And what that lets us do is to draw radii. The radius of the polygon is the distance from the center to a vertex. So we go from the center to the vertex of our polygon, and you can see that that is the radius of the circle. And this is the line that we are looking for. This is why we draw the circle, because we want this radius. Why do we want this radius? Because look here. What does that let us do? That lets us draw isosceles triangles. Good stuff. And the word of the day here, the apothegm, this is our new vocabulary. The apothegm is the perpendicular distance from the center to a side. So we are going from the center to the side of our polygon. This one does not touch the circle. It goes from the center to the side and is perpendicular to that side. And now hopefully you can see here that this apothegm, when it is combined with a radius, is going to let us draw a right triangle. And that is really the important part of what we're doing here. I'm going to add one more vocabulary word here. If we draw two radii, the angle formed by those two radii is called the central angle. And this is the angle between two radii. All right, now this is all our vocabulary. What are we going to do with this? Well, let's look at this. Finding angle measures. The figure at the right is a regular pentagon. And what do we know about a pentagon? We know that a pentagon has 5 sides. N equals 5. And we have our given radii and our apothegm. And we want to find the numbered angles. Well, angle 1 here, what is angle 1? Angle 1 is our central angle. So it's worth it to make a little note here. The measure of the central angle, how are we going to find that? Well, take a look here. This is just a circle. So that is 360 degrees. How many central angles are in that circle? The number of sides. So the measure of the central angle is 360 divided by n. And in this particular problem, n equals 5, so we get 72 degrees. Now next is angle 2. And angle 2 is this little angle right here. Now how do we get that? Well, if we draw two radii and the side, and we drop the apothem down and it's perpendicular, the apothem bisects your angle, this central angle. So these two are congruent. We want one of those two. So to find that, it is half of the central angle. So we take our central angle, divide it by 2, because bisect, and we find that that is 36 degrees. And last, we are looking for this bottom angle here. That wasn't the color that I wanted. We are looking for this bottom angle here, angle 3. And how do we get that? Well, that's just triangle angle sum theorem. Our other two angles, we know that this one here is 36 degrees, and we can just do triangle angle sum and find this to be 54 degrees. So that's pretty easy. It's your turn. Go ahead and do the first problem. That was an easy problem. We're given a regular octagon, which means n equals 8. Angle 1 is the central angle. And so 360 divided by 8 gives us 45 degrees. Angle 2 is just half of the central angle. So that's 45 divided by 2 is 22.5. And triangle angle sum theorem gives us angle 3. So we get measure of angle 3 is 67.5 degrees. Being able to do this is mandatory for you to be able to solve these problems. All right. Our postulate here says that if two figures are congruent, then their areas are equal. Now that's not really a big surprise. Congruent figures are exactly the same. So if your measurements are exactly the same, your areas are going to be exactly the same. But why do we care about that? Well, let's look at this here. Suppose we have a regular n-gon, right? Any polygon that we want to talk about. Doesn't matter how many sides it has. It can have 3, 4, 127. Doesn't matter. We have a regular n-gon here, and our side length here is s. It's s units long, and our apothem is a units long. And if we draw our radii, right, we just draw our radii out here, what do we form? We form a whole bunch of congruent isosceles triangles. So what do we know about these triangles? We know that the areas are equal. Now, do we know how to find the area of a triangle? Why, yes. Yes, we do. We know that the area of a triangle is 1/2 base times height. So for this triangle here, what's our base? Our base is S. So the area of this triangle is 1/2 times S. And what's our height? It's our apothem, A. So we now have the area of one triangle. How can we find the area of the entire polygon? Well, our area total is the area of one triangle times the number of triangles. That's just the number of sides that we have. So that's 1/2 times A times S times N. And I switched the order a little bit, but that's okay. It's multiplication. We can do that. Now what I want you to look at here is, what is this right here? S is the length of the side. So this side is S, 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 all the way around. If I take the length of the side times the number of sides, I get the perimeter. So what I'm doing is finding the area of this triangle and the area of the next triangle and the area of the next triangle and the area of the next triangle. Right? That's what n does for us. 1/2 AS is the area of one triangle, and then multiplying that by n just gives us every other triangle. And S times n is the perimeter. Now, why do we care about that? Let's take a look at our next theorem. The theorem here for the area of a regular polygon says that the area is half, that's where the triangle, right? Triangle is half the product of the apothem and the perimeter. Perimeter is the number of sides times the length of the side. So this is our formula for the area of a regular polygon. And sometimes I also like to write this as 1/2 ANS, because the NS is just our perimeter, where A is the apothem, N is the number of sides, and S is the side length. And so that's all we need. Let's look at this in action here. What is the area of the regular decagon? That means n equals 10 at the right. Well, the first thing I'm going to have you do, number 1, write N, S, A. So N equals, S equals, A equals. And then fill in what we know. What do we know? We know decagon. N is 10. And what else do we know? Here's our side length. So S equals 8 inches. And this is our apothem. Apothem goes from the center perpendicular to the side. So that's 12.3 inches. And then step 2, write your formula. You know how this goes, right? That's math. The area of our polygon is 1/2, and you can do AP, you can do ANS. Since I write NSA, I just write NSA. It's multiplication. They are commutative. Now, look right here. This right here, that's our perimeter. So you can do it in my 2 steps, or you can do it the way they do it. The first step they do is find the perimeter, N times S, and then plug it in with the apothem. It doesn't matter. I like my way because we find NSA and then we just put it in the formula. This NS right here is just perimeter, so it doesn't matter what order you do it in. Either way, we find that the area of our polygon here, of our regular decagon, is 492 inches squared. All right, it's your turn again. We'll go up to here. Go ahead and pause the video and do the next 2 problems. These problems were pretty easy. We were given everything we needed. In the first one, we're given a regular pentagon and the apothem length and the side length. So I wrote NSA, 5 sides, side length 11.6, apothem 8 centimeters, Wrote my formula, substituted in 232 centimeters squared. Second problem says if you reduce the length of the side to half its length, how does that affect the perimeter? The perimeter gets cut in half as well. You add up the sides to make perimeter. If you only have half the length, you have half the perimeter. All right. Yes, that was too easy. So what happens when we are not given all of our parts and pieces? Well, we use chapter 8. So let's look here. Using special triangles to find area. Now, I will tell you right now that you will use special right triangles if your polygon, we don't need words, we have symbols. If your polygon is a triangle, a square, or a hexagon. Those are the only three, that's not a very good hexagon there. Those are the only three figures that we can use special right triangles for. Okay, so let's look at our first one here. Let's look at our problem. We have a honeycomb that is made up of regular hexagonal cells. The length of a side of the cell is 3 millimeters. Find the area. Step 1, N equals, S equals, A equals. And what I'm going to do, we are only interested in this triangle right here. So I am going to go ahead and redraw that triangle. Okay? So first off, how do we find everything we need? Well, what do we have? We know the number of sides is 6. We know that this side here, our sides, are 3 millimeters long, and we need an apothem. Well, first thing I'm going to start with here, I'm going to find my central angle. So 360 divided by 6 is 60. And then I'm going to take 60 and divide it by 2 and get 30 degrees. So this right here measures 30 degrees. That means this right here measures 60 degrees. And look what we have. We have a special right triangle, which means I am immediately going to label x, 2x, and x square root 3. Now, do I know any of the lengths on this triangle? Well, I know this bottom length. Now, what you're going to want to do is you're going to want to say that that is the length of the side. It is not. We are looking at this length right here. And that length is half of the side length. So I am going to write here somewhere x equals half of s, and conversely s equals 2 times x. These are important. You will need to know them. You will need to remember them. This is where you're going to make your mistakes. So this right here I know is 1.5 millimeters. That's half of 3. If this is 1.5 millimeters, I can fill in all of these other sides. 2 times 1.5, this side here is 3 millimeters. My hypotenuse is 3 millimeters. If x is 1.5, then 1.5 square root 3 millimeters. Now, which one of these sides is the one that we want? We still need our apothem. And our apothem is this right here, right? We need a base and a height to find the area of this triangle. So my apothem, I can put in measures 1.5 square root 3 millimeters. Notice how nicely we found that? And then all I have to do, area of my hexagon is 1/2 NSA, and I just substitute in. We had 6 sides, our side length was 3. Be careful here, this is why you write NSA, because what you're finding on the triangle is different from what you need. So side length is S, and side length is 3, and the apothem is 1.5 square root 3. So now when I multiply this, I multiply 1/2 times 6 times 3 times 1.5. And that comes out to be 13.5 square root 3 millimeters squared. All right, I multiplied all my regular numbers and then stuck my square root onto it. And then all we have to do is put that into our calculator and multiply by square root 3, and we get this number here, 23.4 millimeters squared. So either one of these, if you're asked for simplest radical form or to the nearest tenth, those are your answers. I'm actually going to write this right here, 23.4 millimeters squared. Leave some space there. Now, these can be a little bit challenging, but if you draw and label, you will be fine. So now it's time to see just how good you are at this. Pause the video and do the last problem. This problem took a little bit of effort. We were told we had a regular hexagon and the side length is 16 feet, so I sketched out a regular hexagon over here. But all we're really interested in, I drew 2 radii, and then I drew my apothem, and all I'm interested in is this right triangle that's made by that. So I redrew my right triangle over here. And I wrote n equals, s equals, a equals. And I decided, what do I know? Number of sides is 6. It's a hexagon. The side length is 16 feet. And I needed to find the apothem. So that's how I'm going to find my area. Well, to do that, I have to find my central angle. 360 divided by n, 360 divided by 6 gives me 60. I cut my central angle in half because all I want is half of this triangle over here, the isosceles triangle. I want the red triangle in the middle. So 60 divided by 2 is 30. That gives me my top angle there. And that's the important one. So I'm looking for the top angle. It's 30 degrees. That means I have a 30, 60, 90 special right triangle. And so I label x, 2x, and x root 3. Now, I know this bottom side here measures 8 feet because it is half of the side length. 16 divided by 2 is 8. So now I know x is 8. That tells me that I can put 2 times 8. My hypotenuse is 16. We don't need that, but it never hurts to calculate it. And my apothem is this left side over here. That's what I'm after. I substitute in x equals 8, and I get 8 square root 3 feet. So I now have n, s, and a. I write my formula. The area of my hexagon is 1/2 NSA. I put my numbers in. And once again, I multiply 1/2 times 6 times 16 times 8. That gives me 320, and I put the square root 3 on it. So I get 320 square root 3 feet squared, Or we are asked to put it into our calculator and get a more manageable number with a decimal on it. So 320 square root 3 is the same as 554.3 feet squared. So yes, these are a little bit challenging. You are going to have to draw and label for every single problem. So all you're interested in is this red triangle, this little right triangle that we can make with the apothem and the radius. So we draw that out, we find our central angle, divide that by 2, that gives us our top angle. That is going to give us our other angle and probably a special right triangle. We won't get into the non-special triangles until 10.5. So for now, special right triangles. So we're going to be working with triangles, squares, and hexagons for this set. And now I have an apothem. Just substitute my x in there. 8 square root 3, I've got my apothem, I multiply through, and all is good. So draw, label, and write your formula. That's how math works. Draw your diagram, label what you know, write your formula, substitute in, solve for the unknown. I truly believe that if you work carefully and make sure that you do all of the parts of the problem, write down everything like I showed you, that you will do very well on these. So go ahead and enjoy the homework. Don't forget to go do your video quiz.